Hello, myself, Jashwant Chaudhary, Punamneni. Today I will be presenting my full data science pipeline project on credit card fraud detection. I will walk through every step from data collection to building models and finally providing business recommendations. So here we can see project overview. The goal of this project was to detect fraud transactions from a large credit card dataset. The dataset contains over 284,000 transactions with 31 features. I followed a complete data science workflow, starting with data collection, then moving through EDA, reprocessing, the future engineering, model building, model evaluation, and then business insights. And the next one, data collection. Here, I used the credit card.csv dataset using the pandas. The dataset includes time, 28 anonymized futures named V1 to V28, V1 to V28, the amount of transactions and a class label indicating fraud or not. Right away, I noticed the dataset was highly imbalanced with 0.17 percentage of transactions being fraud. See here the core dataset. And then next, I just exploring the data analysis. In this, you can see I explored the data by checking the missing values and looking at the distribution of each future. There were no missing values. The amount of the future was highly skewed to the right. I calculated correlations with the target class and found futures like V14, V17, and V21 have the strongest relationships with the fraud. I also created visualizations like histograms and heat maps to better understand the patterns. You can see heat map and exploring the data analysis. In the next one, no missing is done. And the next we go to the data pre-processing. Here I logged transform the amount feature to reduce the skewness. Then I standardized all the features to have the zero mean and unit variance. I removed outliers using the IQR method, which reduced the dataset about 156,000 rows. This helped clean the data and make the modules more stable. And we go to the next is the future engineering. I used I used the principal component analysis or PCA to reduce dimensionality. I kept the first 10 principal components, which I captured about 70% of the variance. I also applied recursive future elimination, or we can call it RFV, using logistic regression to select the top 15 important features. Then I combined the PCA components, and then I selected features into one final dataset for module training. In the next, we can see the initial models. Logistic regression, accuracy recall, decision tree. Here, I can show you. Here, I trained three models initially. Logistic regression gave about 91% accuracy and a recall of 50%, but very low precision. The decision tree had 99.98% accuracy, but completely failed to detect fraud. So here you can see. Um, because it predicted everything as non-fraud. K-means clustering was also tried but gave a poor chill-out score, meaning it was not separating the data well. And then add on the hyperparameter tuning. Here you can see the analysis. So in the hypermeter training, I used the grid search CV to tune the models for logistic regression. The best parameter was C10. Um, which slightly improved the F1 score for the decision tree. A max depth of 5 and a minimum sample split of 2 improved F1 score for almost 0 to 0.030. I also plotted ROC curves. Logistic regression achieved an AUC of 0.95 and the decision tree achieved an AUC of 0.92. Here the curves you can see. Then I done the advanced models random forest. Here you can see the accuracy, precision, recall F1 and ROCS scores. So in this, I built a random forest model next. It achieved 99.94% accuracy and a precision of 99 point accuracy here and a precision of 0.94% and a recall of 0.69%. The F1 score was about 0.80, which has a big improvement over the earlier models. Future importance showed the features like V11, V4, log transfer amount were the most uh, influential. And then I done the and then I done the advanced models with gradient boosting. Here you can see the scores. So in this gradient boosting model, it had accuracy of 0.99.89%, accuracy is 66%, precision was 80%, and F1 score is about 0.72. It has the highest AUC of about 0.98. Gradient boosting performed slightly better at catching fraud cases without producing too many false alarms. See, you can see. And then we come the business insights and the recommendations. For these results I showed, I recommend developing the gradient boosting model for fraud detection. It catches about 80% of fraud cases with good precision. I recommended setting the model threshold at zero point 0.5. The company should prepare to review about 2000 flagged transactions per millisecond million procedure. It would also help to require additional verification like multi-factor authentication for very high value transactions. Retraining the model every 3 months is important to adapt to new fraud patterns. So by all this data, I can conclude. In conclusion, I completed a full data science pipeline, starting from data cleaning through future engineering, modeling, and tuning. The best F1 score was achieved was 0.80 with random forest and gradient boosting performed even better overall. With these models, the business can now catch fraud much more effectively and reduce financial losses. Thank you. Thank you, Professor. By this, I can conclude my presentation.